So I forgot to write down my answers for this group quiz, so I only know a few of them, remember a few of them, but I had a hard time with.
That's okay.
It's all good.
All right, so number 3, 90% confidence interval for the mean heart rate. Which of the following is the best interpretation of the confidence interval? That's a B, right?
Really nice, I said.
Yes.
Yep.
That's B.
Yeah.
All right, sounds good. Researchers in the University of Mississippi wanted to see whether the reaction time of samples to go or no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate in the go or no-go stimulus, required the student to respond to another. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. So, with the QQ plots, both random samples see that they are approximately normal, but because the distribution of the mean of each sample is normal, since the data have been determined. Isn't that right?
I can't hear you.
You got some funny thing going on with your mic.
Oh, good. That's exactly what I need to hear. Is that better?
Yeah.
Yeah.
Sure.
There we go. I had 2 mics on. Sorry. So for number 4 or 3, I mean, it's C, right? The distribution of the mean of each sample is normal.
That's what I put.
Yeah. Mm.
4 of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
C again, isn't it? No, never mind. No, it's not C.
Isn't it independent samples?
Yeah, they're not. Oh, what the heck?
Right?
Yeah, it'd be.
What?
Yeah, it's C. It's C.
It is C?
Yeah.
That's because each sample doesn't depend on the other one.
Right. And we never use sigma anymore.
And we want to know the difference of means. Okay. That's true. Okay, cool. A researcher is interested in estimating the savings account balance. Customers in the large bank, shaping savings balance in a range sample 30 customers. Means savings account balance.
So that one would be D, because if you make the numerator bigger, then the fraction gets smaller.
Mm-hmm.
Yes, I would agree.
Smaller margin of error. That's D?
Yeah.
Yeah.
Did you guys see D as in dog?
Mm-hmm.
Yes.
Oh, that's, yeah, okay, that makes sense. Sorry, I was thinking about that opposite. Okay, factory makes propeller drive shafts for ships, quality assurance engineering needs to estimate the true mean length of those shafts. Selects 4 drive shafts, measures their lengths, finds your sample mean to be 1,000 millimeters. Or 1 meter, you butt faces. The lengths are known to follow normal distribution, standard deviation is 2 millimeters. Oh, good. Calculated 95% confidence. How do we do that again?
So
You have to find out the t-score, don't we?
no, this is another question I had for a professor that I put on the discussion board where he was like, "Oh, that's a stupid question." I was like, "How do you tell if you get a t-score if you use a z-score on these questions?" He's like, "I admit it's a little confusing sometimes, but this question totally implies it's just a z-score, so it's a z-score because I got it wrong."
Okay.
So it's 0.19 or 1.960, I think. Isn't that the 95% confidence z-score?
Oh, so we have to use the probability applet? Yeah.
Yeah.
So you don't have to. There's set ones for the z-scores and the set ones.
Yeah, 1.960.
1.960. Yeah. So take 1.960 times that by your standard deviation over the square root of the population.
So that's
Doesn't it come to just 1.960?
Yeah,
Why is it? Oh, because of the square root of standard deviation, or no?
it's the standard deviation over the square root of the population. So the population is 4. That's 1.960 times 1.
Oh, so that's 1. Okay, there we go. The lower bound to 3 decimals.
So that would be 1001.960.
That's the upper.
Wouldn't
That's
that be the upper bound?
Yeah, that's the upper bound. So,
And that 998.340.